Hello and welcome to another session in mathematics. In this session we'll be looking at quadratic equation, but before that let us take a review of our previous lesson. Welcome back. In today's lesson we'll be looking at construction of quadratic equation with given roots. Construction of quadratic equation with given roots. Sometimes they may give us the values of x, let's say 2 over 3 or 3. We'll be asked to find the equation whose roots are 2 over 3 and 3. How do we obtain that? So I want to teach us today how we can be able to solve such problems like this and then arrive at the equation that will give us x to be equal to this. Okay, to do that, let us let the values of the equation, the quadratic equation ax squared plus bx plus c equal to 0 be alpha and beta. We know that this is the general form of a quadratic equation, ax squared plus bx plus c. So let the two values of this equation be this. Okay, now if this is the case, it means that x is equal to alpha or beta. Okay, that means that x is equal to alpha or x is equal to beta. Is that correct? Then x minus alpha is equal to 0. This alpha crossing over to meet x will become a negative alpha, or x minus beta is equal to 0. Then forming the quadratic equation, we have that x minus alpha into x minus beta is equal to 0. Okay, so we'll now multiply through. We have x times x to give us x squared. X times minus beta will give us minus x beta, and minus alpha times x will give us minus x alpha. Minus alpha times minus beta will give us plus alpha beta to be equal to 0. Okay, now looking at this, they have x in common. Okay, so if we pair them, we then have x squared minus alpha plus beta into x to be plus alpha beta to be equal to 0. Remember that alpha times x will give us x alpha times this minus here, we have minus x alpha. Beta times x will give us x beta times this minus, we have minus x beta. At this point we have x squared minus alpha plus beta x plus alpha beta to be equal to 0. This is the general formula we use in solving for an equation whose roots are given. We use this when the roots of an equation is given. Okay, so let us take an example. If we are given the values of x to be equal to, let's say minus 1 and minus 1 over 2, and we are asked to find the equation whose roots are minus 1 and minus 1 over 2, the first thing we need to do is to take the sum of this, because looking at the equation we have this to be sum and we have this to be product. Okay, this is addition, this is multiplication. Okay, so we have sum of roots to be minus 1 plus minus 1 over 2. That will give us minus 1 minus 1 over 2, and this is 1 over 1. So taking the LCM, we have the LCM to be 2. 1 into 2 will give us 2. 2 times minus 1 will give us minus 2. 2 into itself is 1. 1 times 1 will give us 1. Therefore our answer is what? Minus 3 over 2. That's the sum of roots. For the product of roots, we have minus 1 times minus 1 over 2, and that will give us what? 1 over 2. Minus 1 times minus 1 will give us 1 over 2. Okay, we've gotten the values of the product of root and the sum of root, and we are given here that x squared minus alpha plus beta x plus alpha beta is equal to what? 0. So at this point we put the value of what? The plus, and then we put the value of the multiplication here, which is the product of root. Therefore we have x squared minus, what's the value of our sum of roots? Minus 3 over 2. We have minus 3 over 2x, okay, then plus our product of root, and our product of root is what? 1 over 2. 1 over 2, this is equal to 0. We have x squared plus minus times minus will give us plus 3 over 2x plus 1 over 2 equal to 0. So what do? We multiply through by 2 to eliminate these 2. Therefore we have 2 times x squared plus 3 over 2x times 2 plus 1 over 2 times 2 equal to 0, and this will give us 2x squared. These 2 will eliminate these 2. We have plus 3x plus these 2 will eliminate these 2. We have 1 equal to 0. This is the quadratic equation whose roots are x minus 1 and minus 1 over 2. Okay, so if you solve this, you still arrive at x to be equal to minus 1 and minus 1 over 2. Now apart from this, there is another way of finding an equation whose roots are given. Okay, let me quickly teach us that. If we are still given that x is equal to minus 1 and minus 1 over 2, okay, we start by saying x is equal to minus 1 or x is equal to minus 1 over 2. Then here we have x plus 1 to be equal to 0. If this one crosses over again, becomes x minus x equal to minus 1. Do you understand? Or we have 2x to be equal to minus 1. Is that true? Then x plus 1 equal to 0, or 2x plus 1 equal to 0. So we now pair this. We have x plus 1 into 2x plus 1 equal to 0. We multiply through. X times 2x will give us 2x squared. X times 1 will give us x. 1 times 2x will give us 2x. 1 times 1 will give us 1 to be equal to 0. We collect like terms. We have 2x squared. X plus 2x is equal to 3x, and we have 1 equal to 0. And that was the same equation we got here. Okay, so these are two ways of solving an equation whose roots are given. Okay, let us take one more example. Let's take one more example. Okay, assuming we are given x to be equal to 2 over 3 and 1 over 4. Let us start using the second method. We have that x is equal to 2 over 3 or x is equal to 1 over 4. Okay, then 3x is equal to 2 or 4x is equal to 1. 3x minus 2 is equal to 0, or 4x minus 1 is equal to 0. Therefore we have 3x minus 2 into 4x minus 1 equals 0. Let's open the bracket. 3x times 4x will give us 12x squared. 3x times minus 1 will give us minus 3x. We'll come to minus 2. Minus 2 times 4x will give us minus 8x. Minus 2 times minus 1 will give us plus 2 equal to 0. Collecting of like terms, we have 12x squared. Minus 3x minus 8x will give us minus 11x plus 2 equal to 0. This is the equation whose roots are what? 2 over 3 and 1 over 4. Okay, we have a problem here. He said if 3 is a root of the quadratic equation x squared plus bx minus 15 equal to 0. A. Determine the value of b. B. Find the other root. Find the other root. Okay, let us start. Pay close attention to what we are doing. You will really enjoy this class. First of all, we are asked to find the value of what? B. And they told us that 3 is a root of the quadratic equation. If 3 is a root, it means wherever we see s in this equation, we should subtract what? 3. So we have x squared plus bx minus 15 equal to 0. Okay, so we have 3 squared because x is equal to 3 plus 3b, is that correct? Minus 15 equal to 0. Then 3 squared is 9, and we have 9 minus 15 plus 3b equal to 0. 9 minus 15, what do we have? Minus 6 plus 3b is equal to 0. So 3b is equal to 6, and b is equal to 6 over 3, which will give us what? 2. So the value of b is what? Is 2. Okay, for the other question, they said we should find the second root of this equation. Finding the second root of the equation means we should now substitute the value of b to be 2 in the equation and then solve for the second value of x. Okay, let us start. They gave us x squared plus bx minus 15 equal to 0, where b is equal to what? 2. So since b is 2, we have x squared plus 2x minus 15 equal to 0. Is that correct? Fine. Then we'll find the sum of roots and the product of roots. I taught us this when we were dealing with factorization method in our junior class. So what do we do here? Our product of root is the middle term, which is 2x. That's the sum of root. Then the product of root is the first term times the last term. These two things. X squared times minus 15 will give us minus 15 x squared. We then find the two factors of 15, which includes 3, 5, and 15. Okay, then we'll find two factors out of the factors of 15, such that when we multiply them, it gives us minus 15x squared, and when we add them, we have what? 2x. Now you agree with me that minus 3x and 5x fits in. 5x minus 3x will give us what? 2x. Minus 3x times 5x will give us minus 15x squared. So we now replace the sum of roots, which is 2 here, with what? Minus 3 and what? 5x. Therefore we have x squared plus 5x minus 3x minus 15 equal to 0. Then we'll pair this. What is common in the first bracket? X is common. We then have x plus 5, such that x times x will give us x squared. X times 5 will give us 5x. What is common here? Minus 3 is common. Then we have x plus 5. Minus 3 times x will give us minus 3x. Minus 3 times 5 will give us minus 15. This is equal to 0. Therefore we have x minus 3 into x plus 5 to be equal to 0. So x minus 3 is equal to 0, or x plus 5 is equal to 0. We have x equal to 3, or x equal to minus 5. So our x is equal to 3 or minus 5. But already they've given us the first root to be 3. So the second root of the equation, which is unknown, is what? Is minus 5. Okay? To refresh your memory of what we've done so far, kindly provide the answer to the following questions on the screen. Welcome back. So far we've been able to deal with construction of quadratic equation with given roots. I will stop here, okay, to continue in our next class. So do well to use the lesson notes on the platform for better information on what we've just discussed, and feel free to drop your questions or comments on the comment section. Till we meet again in our next class, stay safe and bye.